To ensure that we're all on the same page and we all have the basics of React down, let's now have a brief refresher on React.js, understand what it is all about, how React generally works, and how you build modern front-end web applications with React. Now, one important note though, this does not replace a complete React course. It's only a brief refresher having a look at some of the core fundamentals that make up React. I definitely recommend that you also have a look at a dedicated React course, like my React the Complete Guide course, if you want to learn all about React and if you want to ensure that you get the most out of this course as well. We're just having a brief refresher here. Now, in detail in this module, we'll have a look at the React.js basics and understand how React works there and how we can build web applications with React. We'll also have a look at how React manages state and stays reactive and what makes up React in the end. And with that, let's dive right in. So what exactly is React.js? It's a JavaScript library for building user interfaces. And as such, it's all about running JavaScript in the browser. It's a JavaScript library for browser-side JavaScript code. It's not a Node.js library. It's a browser-side JavaScript library. Now, to be precise, React.js itself is referred to as a library because it's very focused on that user interface thing. But it actually started a huge ecosystem with other third-party packages that, for example, help us with app-wide state management or with routing, front-end routing, and therefore effectively you could also call it a framework, I would argue. But these are semantics, not too important right now. Let's instead understand how React works and how we use it. React helps us build user interfaces that are shown in the browser, that run in the browser, and therefore we use it to build the front end of web applications, what the user sees. React does not run on a server. React does not communicate with databases. We use it to build highly reactive modern user interfaces. And we do so by following a declarative approach, which means that in React we rather define the result and maybe different states of the result and under which state we want to render what and want to show what on the screen instead of the steps that lead to the result. That would be an imperative approach, which is basically what we have if we use vanilla JavaScript, where we have to define every step, add this element, add this CSS class to an element, remove this element. This is what we do in vanilla JavaScript. And this can be very cumbersome in very complex user interfaces. We typically don't want to do that if we're building bigger applications, because managing and orchestrating all these steps and ensuring that when something changes, we execute the right steps is very error prone and takes a lot of effort and work away from our actual business logic and from building nice user interfaces, and instead forces us to spend a lot of work on JavaScript primitives, on reinventing the wheel, and so on, and we don't want to do that. So in React.js, we instead focus on the result, and we do so by using components. Components is a concept introduced by React. Basically, these are UI building blocks, which we define, and you will learn how you do that in this module, of course, which we define, and then we compose our user interface from these components, and every component can also define what it should render under which circumstance, and React will then magically wire up everything behind the scenes and implement all these steps in the gray box here for us, so that we don't have to write the steps, we just define the results. This is React.js in a nutshell. Now let's have a look at how it actually works when we write some code. For this, attached you find a starting project. This starting project was created with Create React App, a tool created by the React team in the end, which makes it easy to spin up new React projects and give us a project structure like this. I adjusted it a little bit, but generally it's exactly the same you would get from this tool. Now, why do we need such a tool? Why don't we just import a script in a HTML file and get started? Because React is a bit more complex than vanilla JavaScript. In the end, we ship vanilla JavaScript code, but the way we write the code is a bit more convenient to us as a developer. We can use certain features which wouldn't run in the browser, and therefore this project setup here has a couple of tools included which take the code we write as a developer and actually convert it to code that runs in the browser, so that we have normal code that is executed in the browser, but we have an easier time writing that code as a developer. In addition, we get a development server, which is a simple server that serves our front-end application, so which has no backend, only serves that front-end application, and which automatically reloads or injects changes whenever we change and save something in one of our source code files. In addition, here with React, we're building a single-page application. That's not a must-do, but it's a common choice. In a single-page application, you only have one HTML file, which in the end is returned by the server serving that application, in this case, this HTML file, which itself is relatively empty. But this file will then later include script imports. They will be added automatically by these tools I mentioned earlier, which in the end host and run our React application, which we in turn write here in the source folder with our files we got there. So that in the end, we have a web application, a front end, which consists of one HTML file, where then JavaScript is used to render something on the screen and re-render that something on the screen when it's needed. And that allows us to build highly reactive modern user interfaces where everything happens instantly. Because JavaScript runs in the browser, things happen instantly. We don't need to wait for a new HTML file to be downloaded from a server. Instead, everything is already there. So when a user clicks a button and we want to show a box on the screen in response to that click, boom, it happens instantly because of JavaScript. That's the feeling we want to provide, and we can do that with React. Now, enough talking about the theory, let's write some code. As I mentioned, we do that here in the source folder, where we find an index.js file and an app.js file, both very simple files. Now, let's have a look at the index.js file. There you see we have a couple of imports at the top. This is, by the way, how you import code on the front end. Import something from, and then either a relative path to your own file, or if it's a third-party package, just the package name. And then here we have imports from our own files with a relative path, as I mentioned. And then here we are executing one command in the end, React DOM render. Now this is coming from the React DOM object here in the end, which we're importing from the React DOM library. And that renders this strange thing, which is not regular JavaScript, into this place on our HTML page. This is regular JavaScript, and here we are selecting the element with an ID of root. If we have a look at our single HTML file, that is this div here. So that is in the end where our React single page application will be hosted to, and thereafter React will take over and render everything in that place. So that is what we're doing here, but what is this strange thing? Now for that we need to understand what components are and how React works. So we learned that we have this index.js file, and I can tell you that this file in the end includes the code which executes first when we start our app, and that this renders this strange thing into the place of this div here. Now what is that strange app thing here? We're importing app from this app file, in the end from the app.js file, because extensions are added automatically on the imports. And there what we have is in the end a JavaScript function. This is a regular function, an arrow function stored in this constant, and then we export this constant and therefore this function. Pretty straightforward. But the thing inside of the function is not straightforward. What we return here looks like HTML, just like this looks like HTML. But it's in a JavaScript file. It can't be HTML, right? You can't add HTML in a JavaScript file. That's a special syntax invented by the React team. It's called JSX, and it allows us HTML-looking code in JavaScript files. And under the hood, this will be translated to instructions React understands. In detail, this here is similar to React create element, a method provided on this React object here. And then here, h1, and then here null or an empty object, and then as a third argument your text here. For example, hi, this is React. Different text than before, but it will render something similar on the screen. This will yield the same result, and I can prove that to you if we simply start our development server and try to see this app in action. To start it in the package.json file, we find a script, the start script, which already exists there. And this will in the end use that tooling I mentioned earlier to then transform our code and to start up a development server, which automatically reloads or injects changes when we change something. So here we can open up a new terminal integrated into this IDE, and there run npm start to bring up that development server. And you should keep that server up and running as long as you are working on your code, because when you close it, you can't preview your page anymore, your app anymore. Now, when you start this server, when you run npm start, it should automatically open up a new tab in the browser on localhost 3000. If it doesn't, simply do so on your own and visit it. And there you should see, hi, this is React, which clearly is the text I entered here. So in the end, this here is React syntax, and we could write our entire app with this syntax. But this gets very cumbersome, especially if we start nesting elements into each other. That is why React gives us this alternative JSX syntax, which in the end is just translated to React create element and then what I just showed you. That's also why we need to import React here, even though it looks like we're not using this React object anywhere in this file, right? We have this React text here, but that's something different. So we're not using it anywhere in this file. Well, it gets used implicitly because this is just syntactic sugar in the end. It is translated to that other syntax I showed you. And that is what React is all about. We tell React which elements it should render. And under the hood, it then will translate this into commands that the DOM understands, that the browser understands to render real DOM elements. Now, for example, if I add the title here, which gives us this tooltip that's built into the browser basically, this works. And I save this, it automatically reloads. You don't need to do so on your own. And if you now hover over this, you see this tooltip. This works. Very small here, but you can see it if you test this on your own system. Now, this works because that in the end is translated to React create element h1, then this object which we previously left empty. Here we set the attributes or the properties we want to set on that DOM node which is created here. In this case, title to this works. And then thereafter we have the text. This is how this works, and React will do everything it needs to do. It will create this element, it will set all these properties or attributes here, and it will render the last argument here inside of that created element. And that's also the part where this JSX code helps us, because if in here we have, let's say, another HTML element, we would have to nest multiple React create element calls into each other, which quickly becomes very hard to manage. That's why this JSX syntax here is a great idea, a great invention. So we will use this syntax, and we also use it here in index.js. The difference is, though, that here we don't use it with a normal HTML DOM element, but instead here we use a custom function, because we are using what gets exported in the app.js file. And what we export there is a normal JavaScript function. Well, that is one of the most important concepts of React: components. React is all about components. Now, what does this mean? This function here is of course a regular JavaScript function, but it's also a React component. What makes up a React component? A React component can be one of two things. It can be a function which returns JSX or returns React create element calls, or it can be a JavaScript class that has a render method. So this here, if I change this, would also be a React component. Class app extends React.component. That's important. You have to extend React component. And then you have to add a render method. And in that render method, you return JSX. This is a regular React component as well. And if I save this, you therefore see the same output as before. It works in basically the same way. There are some technical differences, which I discuss in detail in my React to Complete Guide course. Here, it doesn't really matter. In modern React, you can use functional components only, so function-based components, and that's therefore what we'll do in this course. We'll write every component as a function. It's not a must-do, and as I mentioned in my React to Complete Guide, you learn about both types and how they differ, but using function components only definitely is a modern way of using React, and it is therefore the way we will use. But always keep in mind that this is just a regular JavaScript function. What makes it a React component is that it returns this JSX or this React create element logic in the end here. If we return, let's say, an object instead, this would not be a React component, and hence you get an error if you save this. It really has to be JSX code, something which can be interpreted as JSX, like this here. This is how React works. And therefore here I am exporting my own component because this is treated as a component, and your own components can be used in JSX as well. The only important thing there is that they should start with a capital character in the file where you use them in JSX, because this tells React that it's not a built-in HTML tag. App wouldn't be a built-in tag, but that it's a custom component. And this information is important to React, and therefore start with an uppercase character, but then you can use any custom component in JSX. And the cool thing now is that we can build up our application from small reusable components and compose our user interface with the help of such components. And with that, why don't we do that? Why don't we build a simple first React application and see how things work together there? Now, in this refresher course module here, we'll not write a complex React app because that's simply not the idea of this module. We will write a realistic app in the main module later in this course, after this module here, where we will work on the course project. So that's just a refresher here, and I focus on the core React elements therefore, and not on building an amazing application. So React is all about components, and therefore typically we split our app in components. Now let's start without splitting it though, and instead of outputting a h1 tag, here in app, I will use a div, let's say, and in that div, let's add more HTML code. I'm saying HTML here. Of course, it's JSX, but it is translated to HTML, to DOM nodes in the end, right? But it is JSX. So here we could have a h2 tag where we say course goals. And below that, we want to have a list on, or the list of our course goals. And there, a goal could be that we want to finish the course, that we want to learn all about the course main topic, and that we want to, let's say, help our students in the course Q&A section. And that could be some goals. Now, a very trivial application. Now, I don't have any special spectacular styling here, which is why we save that and we get this output. Now I will add some styling, and for that I will add a app CSS file here and import that file into the JavaScript file. This of course is not possible in vanilla JavaScript, but because of that under the hood tooling, which in the end analyzes our files and then transforms the code, this is possible, and this is simply transformed to inject this CSS code into the HTML file as well. Now here I'll give this a CSS class, and there is one special thing. The class attribute like this doesn't exist in JSX because class is a keyword in JavaScript. So it is class name. And this is how you add CSS classes to elements in JSX. This also, of course, is kind of a proof or reminds you of the fact that this is not HTML, but HTML-ish looking syntax. I'll name this class goal list here. And now in here, we can define some styles for the goal list here, and I will simply set list style to none here, remove a margin or give it a margin of 2 rem top and bottom, and a padding of 0. And on every goal list item, I will add a margin of 1 rem, top and bottom, 0 to left and right, and then simply a border of 1 pixel solid, and then this grayish color here, and a padding of 1 rem. And this is very, very simple styling because I don't want to spend a lot of time on writing CSS styles here. Now, maybe one adjustment. Let's actually give the list a margin of 2 rem in all directions. Now we have this list of our goals. To adjust the course goals here at the top, I will also give this div a class name of course goals. And then in the CSS file, maybe at the very top, we can style course goals and there the h2 tag to be aligned in the center, just like that. Now, again, very huge goals, but that is okay for this course here. We're just practicing React. So we got these course goals here. Awesome. This, of course, is a very simple markup. Now, what you often would do in React is you would split this into more components. You would, for example, outsource this list into a separate component to keep every component on its own, relatively lean and focused on one task. For that, we can add a components subfolder here in the source folder. And in there, I will add a goal list.js file. This will hold my goal list component. Now, to create such a new component, we first of all have to import React from React. Otherwise, we can't use this JSX syntax. And then I mentioned that a component is a function. And by the way, you can also create it with the function keyword or with the function expression or with the arrow function syntax I used before, which is the syntax I will use here, but that is not a must do. And then here I export my goal list like this. And now in here, I return this unordered list. So I'll cut it here and then add it here as a return value. And if I reformat that, you see automatically these parentheses are added around it so that this can be nicely formatted across multiple lines. Otherwise, this would not be valid JavaScript. So it is. With the parentheses it is, because then JavaScript knows that this block belongs together. So now we have the goal list in here. And in app.js, we can now import our goal list component. You can name this here however you want. Doesn't have to be the same name as under which you export it here. Only important thing is that it has to start with an uppercase character here in app.js. And I import from the components folder and there from goal list. And as I mentioned earlier, you can omit the file extension here. It's not required. And then here you use goal list like a regular JSX element, like a regular HTML element, you could say. But since we have no content between the opening and closing tag, we can and we have to write a self-closing tag here. This would not be allowed. You always have to close tags in JSX. So this would now be my goal list component. And therefore, if we save this, we see the same output as before. We also get the same styling because styles here are always applied globally, even if you import them into a specific component file. And still, it is a good practice to set up the styles in the CSS file next to the component they belong to. Hence, I will add a goal list CSS file, add my goal list styles there, and import that goal list CSS file into the goal list JavaScript file. This is not a must do, but it makes it easy to find the styles that belong to this component. Keep in mind that styles are not automatically scoped to a component though. The normal CSS rules are applied because all the CSS files, no matter where you import them, are applied globally to your entire page. With that though, we're back to the same result as before. So why did we do that then? Why do we split this up if we have the same result as before? I created the separate component, A, of course, to practice creating your own components, but B also because it really is the core philosophy of React to split your app into smaller pieces. Of course, it's up to you how small you want to split it. Every list item, for example, could also be its own component, and there would be nothing wrong with that. The idea simply is to have small, manageable code files, and later, once we add more logic to the app so that we can also interact with it and we change the number of goals, for example, upon a button click and so on, we of course want to be able to manage a lot of the logic in the goal list component and not in other components. So really splitting it into components has the idea of separating concerns, of keeping your files small, focused, and manageable, which, if you're working in bigger projects, is a huge win because it makes it much easier to manage and work in such bigger projects. Now, thus far, everything in our app is hard-coded though. Now, more realistic would be that, let's say, our goal list is managed here in app.js as data, and we want to render the goal list HTML items or JSX items based on that data. Now, I'll manage it here in app.js simply because later I will add another component here that helps us create new goals. But for now, let's just add a normal constant here to this functional component. Because it is a normal JavaScript function, of course you can do more than just return JSX. And this constant here will have my course goals. You can name it however you want. And this will be an array. And in this array, each goal can be a JavaScript object created here with the object literal notation. Of course, you could also create your own class or constructor function and instantiate that to create such an object. Now, let's say every goal has an ID, CG1 for course goal 1, and then has some text, let's say. And the text here is simply the text I have hard-coded here. Finish the course. So I'll copy that and add this here. And I'll split this across multiple lines to make it easier to read. Because I'll not just have one goal, but 3. So the IDs are CG2 and CG3, let's say. And now I will just copy all that text here into my objects here in app.js. Also that last text like this. And there I can now also get rid of that ampersand thing here. We don't need that here. We can output the text like this, and React will render it properly. So now we have the course goals array, and my idea now is that in the goal list component, these goals, that data here, should in the end be output. So it should be output dynamically in this component, in the goal list component, instead of being hard-coded. So we can remove this code here. Now that leaves us with 2 problems. Number 1, how can we output a list of data dynamically in JSX? But more important than that at the moment, how can we get that list of data, which is defined in the app component, into the goal list component? Well, let's focus on that first, because without that, we can't focus on the other problem. We can pass data from component to component with a concept called props, short for properties. We can define our own, you could say, attributes, which are these props, on our own components. So for example, here on goal list, we could say we have an items attribute or a goals attribute, totally up to you. I'll go with goals here. And that goals attribute, or prop is the common term, so this goals prop, then passes data to that component. Now for that, I don't use a string here, which I want to pass down, but instead I want to pass down my JavaScript data structure, the array here. And for that, here actually we use another special syntax in JSX. We use single opening and closing curly braces. Looks like we're creating a JavaScript object here, but we are not. If you do this inside of JSX, which I am doing here, that's JSX, then this means you want to merge your JSX code with some JavaScript expression in the end. And here we can point at course goals. That is a valid JavaScript expression. We're just pointing at a constant. And what this in the end means is that React will pass course goals here, the value stored in this constant, in this case this array, into this place of JSX. In this case, into this prop, therefore. So goals will be a prop that holds a reference to this array now. Now inside of goal list, we can now receive that goals prop. So let's go to goal list and see how that works. In goal list, we have a function, right? A functional component. Now this function right now doesn't get any parameters. We can change this. We can receive a props parameter here. Every function that is used as a React component, which means it returns JSX, also receives props. This is an object passed to your React functional component automatically by React. And it's an object that bundles all the props you passed to the component. So in our case, goals is the single prop we have. So here we will have an object which has a property with the name of goals that holds the value passed to that prop. So in other words, here I could console log props.goals. .goals because I named my prop goals here. If you chose a different name here, which is perfectly fine, you have to use the different name here. Now if we save that, we won't see our goals anymore at the moment. But if we open the developer tools, we see the array being logged here, and that log is coming from goal list line 6, as you see, which of course is this log here. And there we see our goals data, which means, yes, it arrives successfully inside of the goal list component. The concept of props is a super important concept in React, because this is what allows you to pass data from component A, the app component, to component B, the goal list component in this case. Now let's have a look at how we can output a list of data dynamically in JSX, because here we got a list of goals, an array of goals, and we want to output this as list items here in our unordered list. How can we output an array of data as JSX elements? Well, actually, it's relatively trivial. We will map this array of JavaScript objects to an array of JSX elements because React is capable of outputting an array of JavaScript elements. For that, let me show you how this works. Let's use these single curly braces because I want to add a JavaScript expression here. And my expression here is a simple array, but an array of list items. Hi, and then another one. This works. I output this in my JSX code with the single curly braces because this here, of course, is not JSX, it's an array, but it's an array full of JSX. And if I save this, it outputs hi and this works. We get an error or a warning, which we can ignore for now, but this works in general. Now, since this works with hard-coded data, we can also output our array of goals. So we can output props goals here. But the problem is that props goals is in the end an array of JavaScript objects, not an array of JSX code. So if we try to output this here, it will fail. It tells you that objects are not valid as React child or as React children. So in the end, we can't output plain vanilla JavaScript objects in JSX. Instead, we need to map every object into a JSX equivalent, so into a renderable element. So here we want to map every object into a list item in the end. So on props goals, which is an array, we can call the map method. That's a default vanilla JavaScript method that exists on any array. The map method takes a function, here I'll pass in an arrow function, which is executed on every element of the array you call map on, and then this function here will return a transformed version of that element in the original array, and overall map will then return a new array full of these transformed data pieces. So this function will therefore receive the existing element here, so every goal in our goals array, and then returns a new element. So in this new array returned by map, I want to have a bunch of JSX elements. So here I will just return a list item, which is JSX, of course. And in that list item, I want to output my goal text. Now, goal here is that JavaScript object we have in the original array, because this function runs on every element in the original array and gives you the object in the original array, or the data piece in the original array, as an argument. So goal here is that object which looks like this here. So I'm only interested in the text here. And again, we can output the text by outputting a JavaScript expression here. Hence, we need the curly braces in our JSX code here. And we have goal.text here. My expression is that I access the text property on the goal object. So now what happens here is I map my array of plain JavaScript objects to an array of JSX elements. And such an array of JSX elements is renderable, as you learned. So now if I save this, you see, this outputs my course goals again. Now we also get a warning regarding a unique key that is related to how React re-renders the DOM, and that it wants to do this efficiently. You learn more about that in my React the Complete Guide course. And therefore, whenever you output lists of data with this technique, you have to add a special prop to every item you are rendering in that list, in this case to every list item, and that's the key prop. That is a prop React itself understands, and here I want to output goal ID, again wrapped in curly braces because this is a regular JavaScript expression. So now with that we don't get the warning and we get our course goals. So this is how we output a list of data. With that, this is looking pretty good. We're outputting our list of data. Why don't we now work on adding some functionality that allows us to add our own goals? That would be a nice next step. To output our own goals, I'll add a new component in the components folder. And to keep it manageable, I'll actually create a new subfolder for every component. This is not a must do, but I personally like doing this because then I can quickly find all my components. Of course, you now need to adjust your import here in app.js. My IDE did it automatically. In case that did not happen, make sure you adjust your goal list import to reflect that new folder I added. And then I will add a new goal component here in the components folder as well. In there, add a new goal.js file and a new goal.css file if you want to apply some styling. Now in a new goal.js file, we first of all need to import React from React. You always need to do that, otherwise you can't use JSX in that file because, keep in mind, JSX is translated to React create element. And then here I have my new goal component here. We could accept props, but as long as we don't need them, we don't have to. And then I export new goal. Now in app.js, I want to render new goal. So I will import new goal. Again, the name here is up to you, but it should start with a capital starting character. And I import this from components, new goal, new goal. And then here we can render this above our goal list, let's say, like that. Now this wouldn't work because new goal is not yet a valid React component because it's a function right now, but it's not a function that works as a React component because it's not doing one crucial thing. It's not returning JSX. So let's return some JSX here. And there, to keep things simple, I'll add a form. And in that form, I'll add an input field, type text, self-closing element. In regular HTML, this doesn't have to be self-closing. In JSX, it does have to be self-closing. And then a button, which is of type submit, where I say add goal. A very simple form. And if we now save that, you should see it here. Now let's add some styling to make this look a bit prettier. For that, I'll add a class to the form, new-goal, and I'll import the new goal CSS file into the new goal JavaScript file. And then here on the new goal class, which is added on the form, I'll add a margin of 2 rem in all directions and text align center so that this looks a bit nicer. And now we could also style the input and the button, but I don't want to spend too much time on that, so I will leave it the way it is. Now right now, when you click the button, by the way, this page will reload because right now the default browser functionality will kick in, which is that when a button of type submit is clicked in a form, a request is sent to the server that served this page. Now that's not the behavior we want here though, because here I don't want to send a request to any server because we're not doing anything on the server side. Instead, I want to handle that click with JavaScript. And that is the first thing I'll do here. Let's see how we can handle events, because thus far we haven't done that. I want to handle the submit event of this form here. And React makes that simple. We can add event listeners to any element, not just to the form, but to any element by adding on, lowercase on, and then the name of the event. Now, not every event is supported on every element, but here you got the default HTML elements available. So for example, on a form element, you have the submit event. On submit. On a button, you also have on click, but since it's a button in a form, it's better to handle this on the form itself. Now, what do you pass as a value to on submit though? As a value, you have to pass a function that should be triggered when this event happens. So a pointer to a function. You could do this here with curly braces and then an anonymous inline function, but I don't like that too much. Instead, I will create a new function here. And in JavaScript, you can create functions in functions. So instead of the new goal function, which it still is in the end, I can create a new function. I will create my addGoalHandler. Now the naming is up to you, but I like this naming of having handler at the end of my function name if it is a function that is triggered upon some event. So this is a function. In this case, I'll again use an arrow function, which is not a must do, but I will use only arrow functions here. And onSubmit now can point at addGoalHandler. Don't execute it here, so don't add parentheses. Instead, you just want to point at the function so that the browser and React, in a common effort, can execute this function for you when this submit event occurs. Now, this function will get an event object, an event parameter, passed in automatically by React. And there, for example, we can call preventDefault, which prevents the browser default of sending a request to some backend, which it shouldn't do here because we're not handling this on the server side here. Our server only serves that single index HTML file. It does not have any logic to handle any submissions. Instead, I want to handle it here in JavaScript on the front end in my React application. And for the moment, I'll ignore what the user entered here, and I will simply instead create a dummy goal. And I want to pass that dummy goal to app.js and add it to my course goals here so that it then is rendered here. Now, step by step. We can create a new dummy goal, of course, in that addGoalHandler by adding a new goal constant here, which is a JavaScript object. The ID here could be a random number with math random. This, of course, is not really a unique ID, but it's good enough, and I'll convert it to a string. It's good enough for our demo application here, I mean. And then the text here later will be the text the user entered here. For now, just some dummy text, my new goal. So now we have the new goal here, and of course, we can console log that to see that everything up to this point works. So if we save that, we see our form here. And if I click on add goal, the page will not reload, but instead we see this dummy goal here. And I can create, of course, multiple goals, but at the moment they're not added to this list. To add them to the list, we now need to get that goal out of the new goal component to the app component. Now before, we learned we can pass data around with props, but that was from app to goal list, so to a lower level component, a component which is included in app. Now it's the other direction. We want to pass data from new goal to the parent component, so to the component which includes the new goal component. How does this work? So now we're able to communicate back, and we are actually updating our course goals array in the app component. But what you see is, despite the array being updated, and clearly the new goal is part of the array, our output here on the screen didn't change. And that leads us to a core concept of React, state. React does not re-render this JSX code and therefore the real UI all the time whenever some event is triggered anywhere in the app. So just because I click this button here does not mean that React will re-render the entire screen just to make sure it doesn't miss any data change. This is not how React works. Instead, in the end, you have to tell React when it should re-render. And you do so by using a concept called state. This course goals array here is a regular JavaScript array. Put in other words, React totally ignores it. We have to tell React that it should not ignore it, and that instead, whenever we change this array, it should update the UI, the JSX code, of the component in which we changed it. So in this case, of the app component. Now to do that, we import one other thing from the React package, and that's useState, a function built into the React library, a so-called React hook, and you'll learn more about hooks in my React the Complete Guide course, of course, a function which we can execute inside of functional components and only inside of functional components. In class-based components, you also have a state management mechanism, not focus of this course here, but you could also do it there. But in functional components, you use these hook functions, as they are called, all these functions starting with use at the beginning, to manage state. So to manage data, which when changed, should lead to the UI of that component in which you manage the state to re-render. So here in the app component, I now want to call useState, and to useState, I pass this array here. This is my so-called initial state then. I can get rid of that constant for now. This tells React that this component has some state and that this is my initial state. By the way, you can also have multiple different state pieces and they're all watched independently. But here I only have one main state and that is my array of goals. And I tell React that I have this state and that this is my initial state. Now, of course, I want to get access to that initial state, store it in some constant, so that I can use it in the rest of the component, because course goals is now missing everywhere. So useState also returns something. It returns an array of exactly 2 elements. The first element always is our latest state snapshot, so either our initial state or, once we changed it, the updated state. And the second element of that array returned by useState is a function that allows us to update that state, replace it with a new value, and tell React that it should re-render. So here I will use array destructuring by using square brackets on the left side of my equal sign here to extract these 2 elements I have in the array returned by useState. And there are always exactly 2 elements. So it does not depend on which kind of state data you pass here. useState gives you an array with exactly 2 elements. First element, your current state. So in my case, my array here. Second element, a function to update the state. Therefore, typically we name this set and then any name of your choice. Set course goals in my case. So now I have 2 constants created with the help of useState. First constant holds my state snapshot. Second constant actually holds a function which we can call to update that state snapshot. And we will call that function here in add new goal handler. We can call set course goals here. And now I want to update my course goals by adding a new goal. Now, a simple form of doing that is to simply then use my old course goals and call concat here. Not push, because push modifies the existing item. Instead, set course goals wants a brand new array, which will replace the old array. And concat will also add an item to an array, but it will return a new array to which this item was added. So it gives us a brand new array, doesn't touch the old one, and we then pass the brand new array to set course goals, and React will then use that brand new array to, under the hood, replace the old array in its internally managed state, and it will re-render this component once it did so, and therefore update this course goals constant with the new array in the next render cycle, which in the end means that React will execute this function here. And therefore, when it does so, it will reflect that new data in our JSX code. So here I want to concat my new goal. And if we now save this and I click add goal, you see new goals are added to the list. Because React now re-renders this screen or the parts that need to be re-rendered whenever we update our state. Now, how exactly React re-renders and so on is not the focus of this course. You can learn that in dedicated resources like the official docs or my complete guide. For now, it just suffices to know that React magically and efficiently does re-render the page or the parts of the page that need re-rendering based on the state changes we applied. State is a crucial concept in React, and therefore it's important to me that you understand how it works. useState is how you manage state in functional components, and your state can be anything. It doesn't have to be an array. It could be some text, a number, an object, an array, a boolean, anything like that. useState always returns an array with 2 elements, no matter what your state is. If your state is a number, useState still returns an array with exactly 2 elements. Because the first element then always is your latest state snapshot, and the second element is a function that allows you to update that state snapshot. Whenever you update the state snapshot, React will do two things. It will update the internally stored state data. So for example here, when we add our first new goal, it will replace the initial state with our brand new state, in this case with the brand new array we created with concat. And once it did update the data internally, it will call this component function again and execute the entire function, and hence also re-render this JSX code. Now under the hood, it will not re-render the entire DOM, it will just check which parts of the DOM need to be updated, but it will re-evaluate the entire component. This also means, of course, that it re-executes useState, but useState internally works such that it only initializes that state when the component is rendered for the first time, and for subsequent re-render cycles, it just pulls out the latest state snapshot and basically ignores the initial value we set up here. This is how state works. Now, it is also important to understand that this way of updating our state in this scenario is not the best possible way. So I'll duplicate it and comment it out so that we still have it for reference, but we also see the better approach. This approach clearly works, and in most cases it will work. But you have to be aware that this whole state updating, re-rendering part of React is in the end managed by React. And when you set a new state, it doesn't pause everything and immediately re-render your app. Instead, it schedules the state update. And if you have an application with a lot of ongoing state updates and a lot of work being performed, which is not the case in this application, but can be the case in other applications, then your state update might be deferred by a few milliseconds. That means that actually maybe if a user clicks add goal multiple times, the course goals which are currently rendered on the screen might not be our latest state, because not all state updates might have been processed yet. Therefore, there is a better form of updating this. Instead of passing our new state data to set course goals, you can pass a function to set course goals. A function which receives the latest state, pref course goals, and has to return a new state snapshot. And React will then schedule all these function calls and guarantee you that they are executed in the right order, so that even if a state update was deferred, by the time the update thereafter executes, it guarantees you the first one executed as well. And then here you would simply therefore return pref course goals, which still is an array, concat new goal. It will yield the same result as before in this app, and in this simple app, this approach would have been fine. There is basically no chance of React deferring updates so long that we would end up with an incorrect state. But this is the bulletproof approach which will always work. You only need it if your state update depends on the previous state's data, as this one does. If your state update is a new data piece which doesn't depend on the previous state, you can always safely use this non-functional form. And here, side note, we can of course also shorten this, take advantage of arrow function syntax, and get rid of the return statement and the curly braces, since we have only one expression which we immediately return. So now with that, it works as before, but this is a bit of a safer approach and the recommended approach if your state update depends on the previous state. State is a crucial concept in React, and with our knowledge about state, we can now also make sure that we don't just create a dummy goal, but we actually reflect the real user input. So for that, let's go back to new goal. What we want to do is we want to store the user input in some variable on every keystroke, so that we have the latest value entered by the user, and then pass that entered value to props on add goal, or to our new goal here, instead of that hard-coded dummy text we have at the moment. So here in new goal, I want to capture the user input here and send this instead of my hard-coded text here as part of the new goal. So we could create a variable here, user input or entered text maybe, which is an empty string initially. And here on input, there actually is an onChange event we can listen to, which is fired on every keystroke. So now we can add a function, text change handler. There we will get an event object, and that event object will hold the user input on event target, which refers to the input element dot value. And therefore we could set enter text equal to that. Now enter text will change with every keystroke once we bind onChange to text change handler, like this. Now here in new goal, we can use enter text, so what the user entered here, and then thereafter let's also console log the new goal here so that we can see that this works. If we now save this and I enter test here and I click add goal, we see this works and this is output here. This approach is generally fine, but it can have one tiny flaw. What if we want to reset this after adding a new goal? Of course, we can go to our add goal handler, and once we created the new goal, we can of course set enter text back to an empty string. But of course this won't do anything. If I enter this goal, you see this is not reflected here. Why is it not reflected? Because the new goal component didn't re-render. This is not state we're managing, this is a regular variable. So of course we can change it, of course we can use the changed value, but if we then set a new value to it, this is not reflected on our input because this input only has a connection to the text change handler. It does not know that it should reflect the current value stored in entered text. Now we could tell the input component that it should do so by binding its value prop. We can bind this to entered text, and with that we tell the input component, hey, the value displayed in the input should be the value stored in entered text. If we do that, we'll notice something new. Now we can't type there anymore. If I type here, the input is not reflected. Now if you think about it, that makes sense. What you're telling React is that input should be rendered such that the value is the entered text. With every keystroke, we change entered text, but entered text is not state, it's a regular variable. So that means that we change the variable with every keystroke, but React doesn't re-render the input component. It doesn't reflect the updated value. To React, the value always is an empty string because that was the last time it rendered this component and therefore this JSX code and therefore this input. So we need to tell React that this is some state and that when it changes, it should re-render our JSX code. So again, we can import useState here and convert entered text. Use array destructuring here. And useState is an empty string initially, or has an empty string initially here, because I'm managing my entered text, and the second element is a function to update the state, which I'll therefore call setEnteredText. And now here on every keystroke, I set my entered text to the value in event target value. And here we don't need that function form of updating the state because we have a brand new value that doesn't depend on the previous state. So we can just update the state like this. And now this will re-render this component whenever we type, whenever we call setEnteredText, so on every keystroke, which sounds horrible, but which is great. React will do this in a very efficient way. And therefore, this latest value will be reflected on the input element. And here in addGoalHandler, if we want to update enterText and reset it, we can therefore call setEnteredText and set it back to an empty string. And with that, we now have the best of both worlds. We can enter something here, that all works, but we also can manipulate it and reset after adding a new goal, like this. So this is now another use case for state management. And of course, there are many use cases in a React application. And here we are using state management to create something which is also sometimes called two-way binding. We're binding the value of the input, and on every keystroke, we're updating the value which we then bind back to the input, so that we always reflect the latest value inside of the input, but we also are able to manage this in a state-driven way, so that we also have a chance of manipulating the value from inside our code up here and reflect this back into the input in this case. With that, we have another scenario of state management, and we are now able to add our own goals. This is React in a nutshell. Now there is way more to React, and we'll see way more throughout our course project, where we will build an entire app with React, where we will also add routing and do more complex user input management and so on. But for this refresher, we learned everything we need. Now, as I mentioned multiple times, really also take some dedicated React resources, no matter if that's my complete guide course or the official docs or any other tutorial, if you are serious about React. This course has not the goal of teaching you React from the ground up. I do explain a lot to ensure that we're all on the same page, and I will explain every feature we add throughout this course, but in dedicated resources, you simply get a way deeper and better insight into React, into all its features, including features which we don't need in this course, and how it works under the hood. So that's my strong recommendation. From this refresher, the most important takeaway is that you understand that React is all about components, that components are functions that return JSX or JavaScript classes with a render method, which we don't use here though, that components can receive props to receive data from parent components, that props can also receive functions, pointers at functions, so that the child component, the component used in another component, can communicate back to its parent component, so to the component using it, and that you have this very important concept of state, which allows you to manage data that, when changed with one of the state updating functions, actually causes React to re-render the component and re-render the JSX code and re-evaluate what needs to be output on the screen. This is what allows you to render dynamic content with the help of React. These are all the important takeaways. And again, there is more we will learn and more you can learn about React in general, but these are the concepts which definitely should be clear by now.